Then I would say let's start. I'll do a quick introduction. I'm pleased to introduce you to Daniel. Daniel Patz is working at Deutsche Bahn Digital Ventures, and he's a high-tech investor who's been in the sector for quite some time in the tech sector. He's worked as Chief Sales Operations Officer at a biotech company and also at AWS as Senior Startup Business Development Manager. And at Deutsche Bahn, they invest in various fields related to transportation, such as mobility as a service through Internet of Things and also robotics and logistics. For example, earlier this year, they invested in the autonomous air mobility company Velicopter, and his session will be about the big data in the perspective of connectivity and digital twins at Deutsche Bahn, as you can see. I'm really looking forward to your presentation, and we'll collect any questions in the chat, and I'll hand it over to you now.
Hello, everyone, and thank you for joining us. Tom, can you hear me? Is the voice good?
Yes, I can hear you loud and clear.
Great. I'm very happy to be here, and what I wanted to talk to you about is big data and the perspective of connectivity and digital twins. By the way, I'm sorry for any background noise. Home office is not usual circumstances, or by now it is usual. So forgive me for that. I think I'll present very quickly the DB group in case not everybody knows it and my team. And I thought to showcase here startups that we invested in this field to show you how we use big data and these digital twins and connectivity to make the railway better. So let me just, starting with a few words on the DB group. Deutsche Bahn is a transportation group that's operating across Germany, but also worldwide. It's a large scale of mass transportation. We manage we have over 5,500 railway stations with 33,000 kilometers of rail line. And that's in Germany. Of course, it's cargo. We use cargo rail, high-speed rail, regional rail, but we also have shared mobility, fleets of cars and bicycles. We have companies like Arriva and Schenker that operate outside of Germany. Schenker in logistics, Arriva in mass transportation. We have a lot of digital activity. For instance, one of the most used apps in Germany is the DB Navigator that's used to find rail connections, to buy tickets, etc. So various group. Here's a few of our units, various types of passenger railway transportation and buses, logistics, both worldwide logistics. Schenker does B2B logistics really in most countries, world leader. A lot of infrastructure in the group, the railway, the power lines, the stations. We also accompany infrastructure projects in other countries. Yeah, it's a big group. It's over 300,000 employees. About the fund, we started 5 years ago, a fund of 100 million euros to invest in early stage startups. Now, big data we don't really invest in the big data, but we invest in enabling technologies that help the big data, like tracking and tracing, connectivity, robotics, even satellites for IoT. So we started as mobility as a service focus, and we slowly shifted to Industry 4.0 to really try and help the core operations of Deutsche Bahn. Our focus is global, and we enter anywhere between seed to Series B. Usually we look at Series A's rounds. The first company I wanted to tell you about is Monoliths, is a company we invested in California, a spin out of Berkeley University. It's a tiny chip that you see in the bottom of the screen placed on a coin. it's a proprietary chip that's supposed to be very cost efficient, and it's a tracking device that you can attach to a two-dimensional battery to create an active label, like a sticker, that can replace RFID. And when you have a swarm of these labels, it can be used for e-commerce or intralogistics. And once a big number of items is labeled, like in an assembly line in a factory or in an e-commerce supply chain, you start to get a lot of data coming from the ground up, and you can have a better estimation of time of arrival of parts or of parcels to delivery. There's a temperature sensor and location sensor embedded on the chip. So monoliths for us is a move in big data, because we start to label assets and collect the data. And these labels talk to each other. It's like a mesh network, and they find a way out to the cloud. So in this case, we're trying to improve tracking and tracing. We have a lot of assets, right? Wagons, cargo, infinite subparts of trains, etc. This is the first example. The second example I wanted to bring is a company we invested in Croatia called Gideon Brothers. Gideon Brothers creates robots for logistics. Here in the top right, you see a pallet mover of Gideon Brothers. Now, the interesting thing about this technology is the camera of Gideon. They developed their own stereo camera that's AI operated, and the camera allows to do navigation in something called visual SLAM. It means the robot can navigate and find its way in the space using the camera, even for safety maneuvering. So it won't stop with this normal 2D LiDAR that detect an object and stop, but there's a syntax, there's an understanding of the space, like you see in the bottom right picture, where's a pallet, where's a human, and the robot can share a space with humans. We want to implement this in railway maintenance. In the workshop, there's people, but there's also heavy parts. You see in the bottom left that Gideon took the camera out and started to use it in other vehicles like forklifts to do autonomous actions like loading a truck, unloading a truck, stacking pallets, etc. And here, the big data comes to play, that the camera creates a continuously updated map of the workshop or the warehouse, which can then be used for other applications, like finding a tool. Immersive technology is a virtual reality. So once you have a 3D model or a cloud point, an up-to-date cloud point of a space, there's a lot of application that can be used either by robots or by human users. So in this case, it's an investment in from the big data part in a sensor that collects visual data that can then be used for many applications. Moving on to the next example is Kepler. So Kepler is a company based out of Canada. They make their own nanosatellites that are built for ultra high bandwidth, and they also go in low orbit, so the latency is very low. It's basically built for very quick transmission of small packets of data, and in a certain latitude, they already provide a global coverage with a few satellites in the sky, in space. So as we have IoT devices and assets in many places, not all in places of connectivity, And as logistics, also from our rail cargo, but also our just Schenker logistics, can span around the world in containers on ships or long rail coming from the Far East to Europe. It helps to communicate with these assets through aerospace, and Kepler was our move there. So here we're moving from a sensor that collects data or a sensor that gives visual data, but we're actually looking at the connectivity, how to connect IoT devices with the control center or the cloud to process the data. Here another example that was already mentioned in the introduction. Volocopter is actually an investment that our subsidiary Schenker made. Volocopter is a German developer and manufacturer of heavy lift drones, both air taxi and for cargo. The cargo drone is a cooperation between Schenker and Volocopter. And here we're talking about an autonomous, fully electric drone. So there's a ton of big data involved and connectivity. Volocopter is leading the pack in Europe to be certified by the European Aerospace Agency for commercial flights. Already performed flights in places like Singapore, etc. Yeah, so this is an OEM of aircraft that we plan to use to innovate in logistics and also helping transform railway stations into intermodal transportation hub. You can take a train, and you can take an air taxi or a autonomous car. So that's the long-term vision. There's a lot of big data that goes into aerospace, from the route planning and the weather conditions and managing the maintenance and charging. So that's endless there. We invested together with companies like Daimler, Intel, and others in Volocopter. I think that was the last example I wanted to give. We're looking at more deals. I can't disclose right now what we're doing in this space, but definitely you saw here a few layers of how to obtain big data, how to get it back to headquarters, and then of course trying to crunch it into something that makes sense. Transportation systems are very complex. They have very strong limitations, such as if you have a train stuck on the track, you can't surpass it like you can on the street. Therefore, the implication of any disturbance on a rail network is very severe. Once you have a disturbance in one area, the train that was supposed to be somewhere else later gets delayed, and the spots that were allocated in the stations throughout the route need to get shifted and updated. So as much as I know it's annoying for anyone, including myself, when there's delays in the rail, it's a very difficult network on a large scale to operate because there's this chain of cause and effect for failures, and there's so much assets of electricity and engines and people and weather and engineering. So it's hard to forecast all of that. What Deutsche Bahn is working on doing is a little bit what I showcased in the presentation today, is to try and get from the assets data. So that means sensors, drone inspections, satellite inspections, etc. So the data starts to get collected. Add connectivity across the network to allow the data to arrive in the right speed, quality, reliability to get processed either on the edge or near the edge or on the cloud. Then we have the simulations, trying to optimize and solve for situations of how to dispatch the fleet, how to predict maintenance on all these moving parts. It's a very big endeavor. There's a lot of people working on it. It's a long plan vision, but definitely we think startups can help us reach there. And that's where the entire industry economy is going to, and we're part of that. I think I can end my presentation here and bring it back to any questions from the crowd. I see 2 questions here in the chat room, or one from Lantan. I'll take that one first. Can the trains eventually be controlled by the digital twin instead? So I'll try to repeat the question in a different way, because if there's something I learned in railway is that everything is very complex and sophisticated. Nothing is simple answer, especially in infrastructure that exists over 100 years. And is critical infrastructure. I read it as, could trains be autonomous someday? And the answer is yes. There's already a lot of autonomy in the trains today. A lot of the signaling dictates the speeds, stopping. That's autonomous. It's a little bit analogous to autopilot on an airplane. You still have the pilot, but big part of the trip happens autonomously. Digital twin is, and I'm not a technical person, but I'll try to give it in a just a popular science explanation, is this process of getting data from a physical asset, or let's say not even a physical asset, any entity, to get data from that, could be even a made up entity, then run a logical procedure of testing that data to decide if the entity or asset are healthy or any step is required. And then depends on determination, also suggesting a step or taking a step in response. Now, there could be different digital twins. We could buy a locomotive from Siemens or Bombardier, and we get the digital twin of the engine delivered with the locomotive. So we can have the digital twin of a specific locomotive for a predictive maintenance. Or we can get the whole digital twin of the train when we buy a new fleet to start simulations of how to optimize the traffic. So the digital twin, there are several of those. Could be on the engine level, could be the wheel set that need frequent maintenance and predictive maintenance so they don't break down, and the braking system, which is very critical in railway. What we see more is a vision of twin-to-twin communication. Digital twins exist in different forms for different purposes. In autonomous driving, you would want a digital twin with low latency for fast response. But digital twin to solve the best structure for a bridge or schedule a maintenance for a bridge can have a very long latency. It's not time critical. Therefore, applications will demand a digital twin for a specific application, even for the same asset. Because let's say for latency and speed and accuracy, you'll need to pay money. You don't need every piece of data to go to the cloud in high definition to be processed. There's other data that can come slowly and be processed later. So we have these levels of urgency for digital twins. And yes, we do see, and we have a unit called Digitale Schiene Deutschland. We do work on having autonomous trains that also involve digital twins and cybersecurity and everything around it. I hope I could answer that question and give you a little bit more insight on the complexities that we are looking at, using that question as a gateway for that. And please remember that Europe is connected with trains all across, right? Germany connects Denmark to Switzerland and Italy, and Ukraine and Poland, or at least Poland, connected until Spain. So it's not easy to get all this orchestrated together. There's another question here on the chat. When do you think you'll be able to start a fleet-wide rollout for the digital twins, in the sense of what is the expected timeline? I repeat the introduction to the previous question. In railway, things are very, very complex, so there's not a straightforward answer for this. The digital twin usually will come from the OEM. So we envision, again, I'm using Siemens or Bombardier as an example, or a company that built a bridge for us or a tunnel to also provide us as the operator a digital twin of the asset. In cases that we produce a digital twin, for example, if there is a engineering project and we have a drone unit to fly the drones, we would create the BIM, the building information model of the construction site as the digital twin. But it's not always in our control to have the digital twin. Continuing what I said before, it's more about the twin-to-twin communication. And I think it's just a gradual shift of the industry. You can't put a timeline on it. We have items that already come with a digital twin. We have things that can't be computed yet, like the entire traffic of Germany, or all the movement of all the ships and aircrafts in the world for logistics. That's something that's just not capable yet to be computed, right? So I think it's just an improvement, a gradual improvement, but we're already working on it. That's for that question. Lamtan again, thank you for clarifying my question, as well as great explanation of the digital twin. Are there any other questions from the crowd or Tom? Julian Feil, thank you, welcome.
Yes, if there aren't any questions, I have one last question that's for you personally.
Yes.
Where do you see transportation, cargo, and logistics, the future? Where is it going? What will be the main changes, radical changes that we'll see in the next few years, where also Deutsche Bahn is investing in?
So we're talking about mobility, right? And mobility, I think all of us see changes already. It's kind of weird that we jump on a scooter to get to a train station, and 2 years ago in Germany, there were still no scooters, or in Tel Aviv, a couple of years ago, you had people bought their own scooters. But we kind of forgot that. Now I jump on the scooter without thinking too much. This intermodal of mobility, electrification, localization, this prediction of how mobility can bring me or cargo from one point to the other, I think is the big disruption. We have more options to get from point A to B. Recently, Deutsche Bahn launched together with Google Maps a rollout of partnerships where Google Maps shows live the Deutsche Bahn trains, not by schedule, but by live location, with the ability to then go into the user journey, like the passenger journey, and complete the purchase of what a passenger wants to do, which is a very significant step. I use Google Maps a lot, so now I can have much more access to public transportation. I'm putting COVID aside, even though it's a massive driver or blocker of mobility. it's still hard to say where things are going to go, but I need to say this pressure to go clean in city centers, less pollution, more climate awareness, is definitely driving changes in mobility. Look at a company like Avocargo, which is now rolling out shared cargo bikes. Look at a company called Liefergrün, Send It, that is offering guaranteed zero emissions last mile deliveries. Definitely climate is a big player here. Then I already mentioned this data and ability to do intermodal transportation and the options it opens for us, like to give up a car or you know, it just changes consumer habits. And of course, the holy grail, which is always around the corner, is getting these vehicles autonomous. It's not that easy to make it autonomous on a very large scale. Okay, one autonomous car might work, but all the cars being autonomous and running on electricity is a little challenging when everybody needs the grid and all the cars needs to communicate. It's not that it's not doable, it's just it's a different problem to solve than charging one car or driving one car autonomously. But I think that's the last point I'd like to add, this giving up the driver, which is of course has also socioeconomic. It's not easy socially economic to do that change, but it will have a big impact on cost, on safety, etc. And maybe as a last point, a bonus, this issue of air mobility, which is not weatherproof, but if we see what scooters did to us, to our lives, once the air mobility hits the markets, and it's not too far out, I guess we'll already experience it. Yeah, it's hard to imagine the effect that's going to have on mobility. That's it. Hope I answered your question.
Yes, thank you very much. We're also at the end of our session. I see there's one last question from William. In just a couple of minutes, the other sessions will start. So we can either stay here for just 2 more minutes, or if it's better for you to just answer it through email, or if you're longer here, I'll leave it up to you.
I'll try to answer it quickly. I don't know if I can, too humble to say what is the biggest problem in transportation. Transportation is huge and it has a lot of problems. I'd say that from my point, I'll tweak the question because it's just too big of a topic and I don't even know that much on all the transportation to know what the problems are. So besides the shortage of chips, which is really messing up everybody's life currently, I'd say that the speed of innovation supersedes the speed of regulatory acceptance or procedures. So to get things certified, things could be new devices, new vehicles, new aircrafts, new processes, even 3D printing of parts is slowed down because there aren't rule books or regulations how to certify the 3D printed part. The rule book says to make a part for a train, you need to cast steel in this temperature into a form that is made in these characteristics. And if you followed the casting, then you're good to go. But how do you 3D print that part? There is no certification on how to say it's 3D printable, and it's good, even though the parts, you'll put them one next to the other, they're identical, but you can't certify it. And that goes for drones, which can't be certified because there is no rule book, not in the FAA, not in EASA, how to certify a aircraft that flies on its own and vertically takes off and lands without a pilot with batteries. It doesn't exist. you need a pilot. The pilot needs to have a license. Like you're getting that out. And you can just take it across the board on cameras and everything you need for autonomous. I think that's where we see startups meet the market, meet corporates like Deutsche Bahn, as in a very big issue is how can we get certification to keep the world safe, so people know when they get on a train or an airplane, things are as they're supposed to be, or get into a car. And in the same way, allow innovation to proceed in the steps of where AI is in cloud. Things are running very quickly, mobile apps, right? That's something I think if it's improved will have a huge impact on all of us. Thank you everybody for attending this. I'm really honored that you took your time to listen to this session. I hope everybody and myself, we learned something, and enjoy your conference.
Yes, thank you. Thank you for the great insights, Daniel. It was a pleasure learning from you. And I hope you all have a great day, audience, and you as well, Daniel. And all the best for the future.
Thank you. Goodbye.
Bye-bye.